Okay, so welcome back. Today we're going to take the next step. This is part 3 in our series where we're showing you ways that you can measure the performance of your computer hardware, your CPU, your motherboard, and specifically we've been looking at the GPU, the graphics processing unit. And we've been looking at some software that's freely available that you can just download and use. And in looking at that software, we realized, hey, there are some features we wish we had, or maybe some modifications to existing features. And as many realize, when you're talking about free and open source software, generally the software is developed by people who might have an interest in a certain thing and have some spare time, but their goal is not to give you what you want, it's what they get enjoyment from, what features they want. So as with anything, there are some features we wish we had, and we said, hey, we could make our own software that makes up for those features. And that's what we've been talking about so far, and you can see the results of that. This application we developed here in C# Visual Studio Windows Forms, although you can use any software you want, the basic concepts are the same. And what we did is we looked at a very popular and common piece of free software that's out there for measuring GPU performance, and it is the Tech PowerUp GPU-Z. And you can see here, it gives you a whole lot of information it grabs from your GPU, and it also allows you to select some sensors that are on your GPU. And here's a bunch of sensors that are on my specific GPU, GTX 1080 Ti, and you can select which sensors you want to monitor over time. And here is an example of real-time data gathering for my GPU, where I've got the GPU clock, 1100 megahertz, GPU temperatures, 49 degrees C, performance cap, we'll talk about GPU voltage. And this is real nice to give you an immediate indication of what these values are. However, there isn't a real nice, like you see here in our application, chart in detail over time of what those values are. On the right here with the GPU-Z, they've got a kind of a chart, but in my view, it's of very little use. I mean, it gives you over a period of time what the values are, but it's very squished and it doesn't really give you good engineering view of what those numbers are. So what we did is we took advantage of this down here on the bottom left, this log to file feature, where you can take whatever sensor values you want and send them to a CSV file. And we said, hey, if you do that, we can then generate this simple C# application that reads in that CSV file and charts it and gives us a lot of customizations that we might feel are a lot better than this and than those that are included in GPU-Z. So what we've been talking about is this application here, and in the previous video we talked about some of the C# code. In this video we're going to finish up the C# code to show you how to develop this. And here's an example of what we can use this for. This is about a 10-minute plot of 3 values from our GPU. We've got GPU temperature in degrees C, which is in blue, the fan speed in percent, which is this orange, and then the GPU load in percent, which is this red. And this is logging data from a piece of software called Blender. And what I did is I did a 3D render of this scene using my GPUs. And this scene is something that I developed in Blender. I built all of these objects in 3D, signal generator and a computer and some other stuff, and a computer down here, and windows and a house. And I built all of this from scratch and textured it. And what we're doing is we are rendering this scene, and it takes about 5 minutes with my 2 GPUs. And we are measuring how the different aspects of the GPU respond over time as we start rendering and watch the temperatures go up. And then as we stop rendering, we watch the temperatures decay. And it gives you a really good idea over time how your GPU performs. So you can see as we start the render, the GPU goes up to about 97% load. It's almost fully loaded, and you can see some things you don't see in other applications. It's not really, it doesn't always stay at full load. It might bounce around. So this is something you can look into. And then the GPU temperature. slowly increases over time over the 5-minute render. And you can see also the fan speed in orange stays off for a while, and then it increases over time. And then we stop the render, and quickly the GPU temperature drops and the fan speed drops. So it's a really good way to get a full understanding of what's going on with your GPU or your other computer hardware. So now what we'll do is we'll pick up where we left off before and talk about the rest of the C# code that will allow you to develop this application. So here we are in our C# Visual Studio Windows Forms application. Again, I encourage you to look at the previous videos where we show you some of what we've already discussed. We showed you how to set up this UI, the user interface. We talked about this trace class. Here is the rest of the solution. We've got documents to do, parameters, configure chart, initialize UI. And last time we left off with one of the methods where we have already set everything up and we have opened the file, the CSV file coming out of GPU-Z. And now we are in this parse CSV file method that is parsing the data coming from the CSV file. And we went through all of this and we got up to this point where we have a for each that goes through and reads each line from the CSV file, which is basically a date and then each value that you want to chart. So there's a string in this list of file lines. We've converted everything in the CSV file into a list of strings, and we're stepping through each one, and we now have to parse them and convert them to actual numbers, and then we can chart them. What we're first doing is for each line, we are doing a string.split using the comma delimiter. It's a CSV file, comma separated value. And then we're converting that to a list of strings for each line. Now, the first value, the first string in that list is going to be the date and time that the value was grabbed. So we're going to take reading value 0, which is the first element, and we're going to parse it into a date time, and we're going to call that reading time. And that reading time will give us our X values for our chart, our time values. And the first one will also give us some information about the date that this log file started, so we can grab the first date and use that as the output to our UI to say, hey, this log file is from such and such date. So we have a date set Boolean that allows us to only do this once, just grab the first date in the file. If date set equals false, we haven't yet grabbed a date, we're going to call it log date, which is that date time, and we're going to say that that value from line 0, reading time, is the log date, and then we're going to set date set equals true so we don't do this again. We only do it once. So now, as we mentioned before, the values in each line are going to look like this, but they're going to have some empty characters that we want to get rid of. So this next for loop for int I equals 0, I less than reading values dot count, so each of the values in the strings in the array, we're going to do a string dot replace any blank characters with an empty character, and that will get rid of all the blank characters in each element in the array. So now that we have already grabbed the date that the CSV file started, we can remove that value. So we can go to the list of string reading values and remove the 0th element, which is the date time value. We also want to remove any empty values in that string. So reading values dot remove all strings where string is null or empty. So we're getting rid of the date time, and we're getting rid of any empty elements. So now that we've removed the date time value from this array of strings, we can now focus on the remaining elements, which are actual reading values. So for int I equals 0, I less than reading values dot count, we're going to go through all the remaining values, which is basically, in our case, a GPU temperature in degrees C, GPU load, And we've already gotten rid of this and also the blank element. So now we can go through and convert each of those readings, convert to double the reading value, or at least we can try. If it fails, we'll just skip and go on to the next one. And then we can add our latest Y vals, that value that we converted to double, and add that to our list of Y vals that we're going to chart. And that is going to be the ith element in our traces list. Again, we instantiated a trace object. So for this trace, we're going to add the latest value. And we're also here going to update the X vals, which is the sample time, with that reading time that we grabbed. So now for this reading, we've added a new Y value, a new X value. Then we can go through and do it again for the next line in the file and just keep doing that for all of the readings in the file. So we've now updated the X vals and Y vals, and what we can do is we can chart it. So chart data, and this is just going to take that data and chart it. Keep in mind we have the possibility of 4 traces, so we're going to pretty much duplicate the same thing 4 times. So chart data, we're going to assign traces to axes. Presently, we're not going to use that. We're going to ignore that. We can talk about that later. It's not really important. What we can do is we can get the log date that we came up with before, convert it to a short date string, and put that in our label on the UI to say, hey, this log, the CSV is dated, whatever the date is. And then what we can do is configure the UI and the chart for the first trace. And that's what this code is going to do. Then we're going to do for the second trace, the third trace, and the fourth trace, and they're all pretty much identical. We're going to set up the checkbox. This checkbox, we're going to name it based on the name that we read in. So traces0.name is going to fill in this checkbox trace1.text. We're going to now make it visible since it exists. Label 1 visible, label 2 visible. Those are the labels associated with this. These labels are going to read the min and the max. And then we're going to grab the minimum and the maximum from this Y vals. And we're going to say Y vals min.text. So you can use this minimum to get the minimum in a list of Y vals. Convert that to string and put that into the label minimum.text, and same thing for maximum. Label maximum.text, traces 0, Y vals min to string. And then now that we've got the X and Y vals, we can do a chart 1 series 1 points, data bind XY, X vals, and traces 0, Y vals. Again, we've done many videos on charts to show you how to do this. I encourage you to look at that if you're not familiar. But basically now we have sent those X and Y vals for all of the points on that trace to the chart to have it chart. And now we're going to do the same thing for trace 2 if it exists. So if traces.count is greater than or equal to 2, we're going to go through and do the same thing. Set the traces 1 name, set them visible, set the text for traces 1 to min and max, and then data bind that to the traces 1 and the X vals to series 2. And the same thing for trace 3. You can just pause and copy and paste. Same thing for trace 4. So at this point, we have successfully charted everything. And the only other code we have to deal with is these event handlers for the checkbox for the traces 1, 2, 3, and 4 if we want to enable them. And they're all going to look identical. If check trace1.checked is true, then we can do the dot enabled for that series, set that equal to true. If it's not checked, then we're going to set enabled equals false, and that won't be visible. That trace won't be visible. And we do exactly the same for the others. Trace 2, if check trace 2 is checked, we enable it. If not, we disable it, and so on for 3 and 4. And that's about it. We've just got the button exit as application exit. I've also added, and we'll talk about this later, the ability. You can see here if I start it up, we do have the ability to change manually the minimum and maximum chart values for the left-hand axis. So I can say the minimum is 75. So you can see the right-hand axes don't change, but now on the left it goes from 75 to 80. So you can do some manual modification if you want to zoom in, and we'll talk about that in a separate video. But that's about it for the C# code. Now in the next video we're going to talk about actually using this and looking at this data and figuring out what's going on with our hardware and what do the different values mean and how we can compare them, and also look at, like, there's a performance cap that you can measure with GPU-Z, which tells you the reason why the performance was capped. And we can look at that, and we're going to plot that and look at the results and see what the different factors are. So that's about it for this one. And if you like any of these videos, I encourage you to hit the like button, subscribe, hit the bell notifications. But most of all, please let others know that we're here so we get some views. Really appreciate it. Otherwise, take care. Have a really good day. Thanks.